Yeah, well, I can provide some context of this meeting. So I think the ISO material view have been discussed in the community for a long time, right? Thanks, Yang, who have been driving this and be patient and also be persistent, address feedback. And we also have quite a few folks who are in the heavy involved discussion, like Benny Chow, Walla. I don't have see Walla join today yet. So, and also Dan. So a lot of folks have been contributed, but we have been stalled for a long time. We never get to the finish line. We're always close. I think Yang spec PR have been really close, but we never get to the finish line. I think in the last committee thing, Tala was asking, hey, where are we with material view? Should we have Tala and Dan was suggesting, hey, maybe can we have dedicated meeting to kind of discuss this? I think this seems a good idea. That's why we set up this dedicated community thing meeting for the material view. And now my intention is that we're going to continue to have this maybe once every 3 weeks, same cadence as I for community think, which is alternate on the week. And until we finish it, let's get this meeting going. Maybe hopefully in 2 or 3 meetings, we can get the consensus, we can get it finished. So we should not lose momentum again and stall for another 6 months. Let's just drive this momentum until we get the finish line. So that's the purpose. And so yeah, for today's meeting, I think first, I assume everyone have looked at the spec PR Yang have created for a long time. So previously, I think Walla have some question on the view identifier, and he started separate discussion set on that topic. My understanding that he had kind of okay with not continue to push on that area and kind of okay with the spec PR that Yang has. So, but Walla not here. That's my understanding was his latest stance. So I don't know if anybody else have comment on the table identifier discussion from Walla. So yeah, I think maybe the first one does anybody have any other questions or concerns with Yang spec PR? Maybe we can start with that. Yeah, Tala.
I just read the spec, and I also read your document to understand it. I have just one question. Is there any specific reason we are designing the materialized view as a nested materialized view? You know, is there any specific requirement? That's why we are doing that, or it's just we decided to start with the nested.
So Tala, is your question? Do we have a use case for like a chaining to material view? Are you asking to it?
Yes.
Yeah, well, I do hear a lot of use case on the material view chain, because material view in other way you can think of like replacing ETL. You use material view to do kind of ETL, and you can chain those ETL using material view chaining. So that's definitely very common use case, chaining material view.
Okay.
Yang, go ahead.
And I think that's depending. So this is kind of the spec. I could imagine that you have kind of an engine configuration where you could maybe add a configuration option to say, I mean, you could also maybe if you specify, it depends how you store your state in your storage table state, right? So, and if you configure maybe your engine that you don't want to use nested views, you could still only put like the view version in there, or you could, and I think that was also like Walla's concern that this forces you to use kind of this nested views, but you could also just store all the dependent tables in the storage table state or refresh state, and then don't use nested views. But like if we allow for also referencing materialized views, it gives us the opportunity to use nested views, but it doesn't force us to do so.
So since I was discussing that source material view, maybe I can share the screen for that document. I think this is where we were discussing. Right. So this is the kind of special design scenario here. So we have a top level material view. It will reference two material view, MV1, MV2, and they may both reference to the same base table A. So if we talk about the two options, if we treat the material view V1 and MV2 as a view, then we, based on the view spec, then we're going to recursively checking the state, right? So we have source view state, that's all the view definition, and source table state. Now we may need like a table A, and we need to check the state twice because based on the image, that's where we're going to refresh state relative to. And the Benny was pointing out this actually not supporting the view spec today because today the view spec will say, hey, we can only have one entry. We don't have the lineage information in the refresh table state. So this is the one option. The second option, if we treat the material view as a material table, then on the table state, we just have MV1 storage table, MV2 storage table. We don't care whether MV1 storage table is kind of how it's stated relative to its view definition or its source table. We just say this storage table is the MV3 is refreshed based on MV1 and MV2 storage table. So that's the option of like treating the source MV as a material table. So the pros and cons of this one is the refresh state is a little simpler. We don't need to track the lineage, right? And also allows more flexible interpretation of the staleness. An engine can interpret like MV3 as fresh as long as MV storage table is refreshed based on the MV1 and MV2 storage table. They can interpret this way, but it also can allow, if an engine wants to interpret the freshness of MV3 recursively, it can still do that. It can just check, okay, what's the MV3's view definition and check out all the MV1 and MV2 and check out their source table if they choose to do that. But this option gives us the most flexibility. Seems to me most people are kind of onboarding with this option. I think in the spec PR, Yan also, I think Yan is also here. Yan made a good comment on the, yeah, Yan, do you want to, I saw you have a comment on the PR if you want to speak.
Yes, so just to kind of reiterate the comment that was sharing yesterday, I think the major point difference between option 1 and option 2 is that, or actually, sorry, I think the major point that makes at least option 2 more interesting to me is that the fact that we're using this as a nested materialized view on top of materialized view. Option view 1, which still use materialized view as the normal view, makes it not much of a difference between the usage of materialized view on top of normal views. And I think this lost the benefit to the engine who, that in my assumption, most likely going to build the most outer materialized view based on the inner materialized view instead of the normal view. I think option 2 will make it likely much easier for the engine to do operations based on how the outer materialized view actually gets generated instead of using that as a normal view, which requires the engine to iterate into the most inner nested child again and lost this benefit.
Yeah, I think I totally agree to that point. Basically, Yan's point, if we want to treat it as a view, then the MV1 and MV2 might as well just be regular view instead of material view. Yang, go ahead.
I have a question. How would we store this in the refresh state? So typically you have the materialized view and then you have an identifier for its storage table, right? And the identifier is different. Would you store in the refresh state, like also for option 2 here, would you store the name of the materialized view, or would you would store the storage table name? right?
Yeah, that's a good question. I would think the storage table name, the identifier, because that's where we check. We're going to need to check the snapshot ID of the MV1 storage table, right? So probably we need that identifier.
I was like, another option would be to store the name of the MV. And once we kind of want to check for what's the current view version or snapshot ID, we see that it's a materialized view. And then we go to the storage table, but this would still give us the option to at configuration or by configuration choose either one of these behaviors. You could treat it, if you configured it in this way, you could treat it as a view, or if you configured it to be used as kind of this recursive materialized view, you could just fetch the state from the storage table. But you would kind of have the option because you could get the storage table identifier from first looking at the view. It's one more hop over the network to get the required data, but this, like if you only store the storage table identifier here, it wouldn't be able to treat it kind of as the first option.
Well, we also have the MV1 identifier here.
Yeah. Okay. Yeah. Actually, yeah. Okay. Mm-hmm.
But why wouldn't you? If you are referencing the materialized view as it is defined in the actual view text, right, along with the snapshot ID, you know it's a materialized view, and then you can associate that the snapshot ID should be from the storage table, and we just have that logic to look it up that way. And that avoids needing to recurse into it because you know that that's, you know, any change to that materialized view would have to be reflected in the actual snapshot ID. So if something has updated it, then you know that you're out of date. I guess the only question is you still need to determine whether or not that materialized view is fresh or not. So you have to recursively go and evaluate that materialized view, right?
Correct. Yeah. If we want to choose the recursive evaluation of the freshness.
Yeah, but that also gets to, you know, yes, we know that we need to do that. We're already doing that for the current materialized view that we're working on. So you do need to recurse and evaluate the freshness. But as a optimization, of course, we have talked about a long time ago, like catalogs could provide hints as to the freshness state when they actually load the materialized view. So you can avoid some of that extra work, but it's basically just a recursive problem of how do I validate the state all the way down? And I think you have to do the validation all the way down, but do you need to track the state of every table all the way down? No, you can rely on that materialized view to then define its own state. Talent?
I have concern about, you know, the determine the state, auto state for the, you know, the nested materialized view. I believe that the materialized view has to rely on the just one level below. And if it is fresh, then we should assume the fresh, because I read, you know, the so many documents before this meeting. Basically, AWS say that cascading fresh is the problem. Redshift is support that, and also Oracle is limited with 10 or 20. I don't remember exactly depth or the cascading, you know, the auto refresh or the getting the information that way. You know, that's why initially I asked that, you know, is there any deliberate reason to have the nested ones? I believe each materialized view should depend on the one level, you know, the below whatever we have. It can be table or materialized view, and you know, we don't need to look at kill the table, you know, whatever the actual source table.
So I agree. I think in practice, a lot of engines probably only determine freshness based on immediate patterns for the source material. I think that seems to be the practice most of the time. That's also my understanding.
I question that. I think we should validate that, because that saying that we only determine freshness based on the state of the, like a child materialized view, and don't recurse down means that can get very confusing to understand why you're getting different results
But this is actually for any materialized view, this is the issue, right? The slowly changing dimensions and the like join and aggregations, those kind of things are the issues. And that's why I was saying that, if we depend on the immediate child, then each materialized view refresh themselves, automatically, then we actually have the latest information.
Well, but we're not assuming automatic refresh right here, right? That we've not discussed anything about like, hey, I noticed that it's not fresh and we trigger a refresh. All of those, I think, at this point are assumed to be manual refreshes. Like somebody has to call refresh on it. All we can determine is it fresh or not?
That's why I'm saying that, if we don't call the automatic refresh, but some process has to be refreshed at those tables, right? If it is fresh, then it is fresh. If it is not, then we cannot do anything else even after the immediate child. Because if immediate child is not fresh,
I agree with that, but we still need to determine, is it fresh or not? And that's kind of the question, right? So you have to cascade through all of the materialized views that are referenced in order to make the determination, is it fresh or not? Because I can't just look at the materialized view and assume that because my snapshot matches the snapshot of the materialized view, that all of the materialized views dependencies are also met. That's not true. So I have to go validate the freshness of every recursive reference.
So yeah, I'm not saying that we should not support recursive evaluation, but I am saying option two, first of all, option two allows us to do both. But what I'm saying earlier, I think in practice, what I have seen so far, I think a lot of engines they support the semantic or just evaluate the fetch based on the immediate parents, which is source material. But I'm not saying we should not support recursive evaluation. Yeah.
I think we should make sure we capture what we're using as reference material for that, because I think that's particularly dangerous. Because it's then really confusing. I can have like different views, or different, if I access the materialized view directly versus through a reference in another materialized view. In one case, I get results. In the other case, I get that it's not fresh.
But I don't think we are determining if we are putting a flag saying if it's fresh or not in the view itself. We let the engine make the decision, right?
Yeah, it's the engine that has to determine whether it's fresh or not. So if I'm evaluating materialized view, I can go and look at all my dependencies and make sure that they are up to date with what the storage table state is. But if one of those dependencies is a materialized view, I need to descend into that and make sure that that materialized view is still fresh.
Well, engine may not implement that semantic. They may just, hey, as long as my, for example, in this case, as long as MV1 and MV2, if MV3 stored table is fresh according to MV1 and MV2 stored table, engine may decide, hey, this is fresh. This is the semantically implement. They say MV3 is fresh.
Yeah, that's what I'm arguing that that's probably not a good thing, because that means that I can read from MV3, but I can't read from MV1.
Why you cannot read from
MV1 is actually stale, right? So it's not fresh, but if the engine is saying, well, I only evaluate one level deep, and my reference to MV1 is still current, I'm going to give you old data.
So yes, we could have a scenario if engine query MV3 is at fresh, but the engine at the same time when engine query MV1 is not fresh yet. That could happen with if we treat MV1 as a solid table.
And if you think about it, in typical, data modeling scenarios, both of those may be involved in the same queries, right? In fact, you could have multiple MVs that reference the same table, and because they were created or refreshed at different points in time, a reference to MV2 may be different for one, like MV4, than it is for MV3, and you're using those same tables in the same query, just at different states in time. And so this is why I think it's particularly dangerous to just only do one level of validation, because untangling those problems is really complicated. Like understanding, hey, why did my join like filter out records? Oh, it's because my MV2 state was different for MV3 and MV4 that were both leveraging MV2 in the representation. How do you diagnose that problem?
But unless we store two versions, wouldn't the other way also introduce problem for the materialized view that derive the freshness state different? Sorry, for the engines who derive materialized view state differently.
You would run into the problem of you need to refresh MV2, and then you have to refresh MV3, and then you have to refresh MV4 in order to run whatever that query was, because it's, you know, it's touching all of those things. But basically, you need to have a fresh state, and you're not relying on some intermediate state somewhere in your dependency tree.
So, but with the option 2, we can still implement a recursive behavior if engine choose to. Right. So engine can still recursive. Yeah. So
require.
Here we talk about how do we represent the request state, but whether what's the right semantic? Do we require recursive or not recursive? In the end, it will be an engine decision. So because Iceberg cannot enforce that the evaluation semantic, but we can. If we go to option 1, we're going to enforce only one way of evaluate the freshness semantic.
I mean, we can define it as a requirement for how you evaluate freshness. So I wouldn't say that we couldn't define that behavior. I think it's worthwhile doing what you did, Stephen, like documenting like what are the cases that engines don't, you know, recursively evaluate freshness, and make sure that we have a good understanding of like what the standard is out there, like what people are actually doing. I haven't looked into it, so I actually don't know. I just find relying on intermediate state like that incredibly dangerous for the examples that I gave.
But your example also, you know, the incredibly computational expensive too, right? Because you need to refresh all of the MVs and aggregation, joins, and even the refresh order is important. Because if you refresh one MV, which in the join, if you don't refresh one MV, which is join for the other ones, then you need to create a DAX for that specific job, you know, when I queried something else.
Yep.
I think that great example. I think if a user query MV1, yes, we care about MV1's freshness, right? How it's relative to sort table. But if a user query MV3, you can also argue, okay, if you think about ETL pipeline, MV3 can be just one ETL output. I only care about its state relative to its parent. I think in that sense, some user may think that semantic is acceptable. I'm not saying it's always the preferred semantic, but I can imagine in some cases this is a valid semantic. Hello.
Yeah, I definitely buy what the Daniel say that, you know, the freshness is important. Otherwise, we keep, you know, the emitting the useless data when we do the ETL and other things. My concern is that, you know, before this meeting, I just did a research with, you know, the Oracle, AWS, Snowflake, and BigQuery. BigQuery and Snowflake, they don't support the nested ones. And the Snowflake has dynamic tables, which is similar to MV, but, you know, it's not exact. But the Snowflake NV and BigQuery MV is just a single layer. And based on the documentation, what I learned, they are using the MV to optimize the query. You know, when you query the main table A, you just query it. And because they only have this one level MV, and they look at the available MVs from that table, and which one's DAG is similar to query's DAG, and they replace the, you know, the small portion of the graph using the MV if it is fresh. This is a good query, you know, the optimization for the engines. We are looking from the top down, but they are looking from bottom up.
So, yeah, I see that two broad use cases of material view. One, I would call it synchronous material view, where they probably care about the freshness all the way to the leaf. They really care about the correctness. I mean, everything has to be perfectly fresh all the way in the whole hierarchy. So second category, probably asynchronous material view, where they kind of like replacing the ETL pipeline. Hey, you use material view to change the ETL pipeline, right? If you think I'm building ETL pipeline, I have a table 1, table 2, then downstream table 3. If I'm contributing table 3, that's all I get. I cannot check, hey, is the linear chain, is my upstream fresh? So in terms of the asynchronous material view, probably the freshness, maybe they care about just immediate pattern. For synchronous material view, will they have to require everything to be fresh? Sure. You may want to evaluate it recursively to make sure everything is fresh. Yeah.
Oh, one question I had is that can it be possible that Trino treats a materialized view stale and Spark treats it as fresh? So now, even though it's the same materialized view in Iceberg spec, both engines behave differently in one scenario. So is it because of that we want to define freshness as all the way down to the leaf tables, everything is fresh, and hence we declare materialized view as fresh because of the interoperability angle? Or
I guess that's why the question is, should that the user have input on how they define the freshness? Or is it all only up to the engine?
No, we are designing the spec, right? If we tell this in the spec, hey, engine has to resolve the freshness in this way, then this is the source of truth. If engine doesn't implement it that way, which means they are not following the spec, they just implemented their own materialized view. Even today, I can implement a materialized view with Link, for example, but it doesn't mean it is Iceberg materialized view.
Yeah, I'll come back to my earlier two category. I think for synchronous material view, that typically means the engine will need to refresh if any of the options not fresh, so they refresh in place. If we use asynchronous material view like ETL pipeline chaining, then they don't have to refresh the ancestor source material view. Sorry, yeah, go ahead.
Yeah, I wanted to refer to the previous comment. I thought that it might be more difficult to prescribe every engine how they have to treat the freshness. And I thought that if we design the spec in a way that it can be interpreted flexibly so that every engine kind of can still use it, can maybe still interoperate it with it, but still has maybe the same semantic as the materialized views they already have or something like that, that would be valuable. But that was just my opinion, and it's also open for discussion. I just wanted to add it.
Okay, I've been doing a little real-time checking of myself, and I realize materialized views across the industry are not where I thought they were. So it's also true for Postgres that they don't check any validity of any of the materialized views. In fact, they don't do anything to validate the freshness of materialized views. So stale data and materialized views is apparently a well-accepted industry practice. It seems particularly dangerous to me. So I think what we probably want to do is, I think as Stephen is suggesting, maybe call it out and say that engines can implement different behavior here, but it is acceptable given standard practice that materialized views referenced from materialized views may include stale data.
Yeah, I think I talked about you use Snowflake example. Tyler mentioned earlier, Snowflake material view is always synchronous, like a recursive evaluation, everything refresh. But Snowflake dynamic table is asynchronous, and they don't have to recursively evaluate. So that dynamic table can map to ETL pipeline use case. So I would imagine from use case perspective, there's two categories. I'm not saying how engine should always implement that way.
Yeah, I think that that's a good point to just say that there is variation in how engines handle this, and we can't, like, If it was something that was pretty standardized, then we could enforce a particular approach and just say this is how it's done. But even like, so in Postgres, apparently there's no validation done. So they don't even check the state of the materialized view. They just return whatever the materialized view data was. And I assume that because we have all these different implementations, we're going to want to accommodate different behaviors. And all we have to say is like, you need to define what that is, and users shouldn't expect that they get, fresh data for nested materialized view references unless it's explicitly supported by the underlying engine, right? If you're going to build it, do it right. God.
Hi, let me quickly introduce myself. I'm Gaurav. I'm tech lead for Materialized View for AWS Redshift. So I just wanted to bring some perspective on some of the choices we made in case it is helpful. There are three use cases in case of cascading materialized views we have considered. One is the ETL, and therefore when you're doing refresh, what do you consider as stale, which was the topic here. What Daniel was saying just now is more on the querying side. So there are two use cases there. One is what we call automatically rewriting the queries using materialized views. Their customer does not know that the query would actually use materialized view, and that's where the whole depth of staleness has to be explored. On the other hand, if the customer is, this is the third use case, if the customer is querying MVs directly, this is, the Redshift also returns whatever is stored in the in MV at that time. And the use case there is what we call snapshotting use case, or sometimes it's called semantic views, where actually the customer does not want those MVs to reflect the current table updates just because the updates are coming too fast. And they don't want the querying side, let's say a dashboard, to reflect these partial updates coming into one table, not in the other table, and so on. So they maintain like a time window of 1 hour or so between updating the MVs and the fast ingestion which is coming into the table. That's all. Thank you.
But so like an alternative to that would be to be able to define the freshness guarantee on that MV, which is something, that if you can say, hey, freshness window is 60 seconds or 5 minutes or something like that, then the enclosing MV wouldn't have to refresh or validate, within that amount of time. And as opposed to just like operating on stale data, like always, you could use other mechanisms to kind of achieve that same result. But it does look like there's standard practice around just like using stale data for materialized view references. So despite my like personal misgivings about that, like I think that just means we need to provide the flexibility so that implementers can reuse their existing infrastructure to support this, as opposed to making hard requirements that are going to be then hard to adopt.
Yeah, I say Andre also shared a link to Starlogs where they have both synchronous and asynchronous material view.
Does that mean is asynchronous versus synchronous basically that synchronous will just refresh things automatically? Or is it?
Yeah, I think it should require trigger of the refresh of the, if it's not refresh.
So I really enjoy with the Snowflake document, to be honest. Even though I am working for Google, that your guys' website is really good. For dynamic tables, there is a comparison table to about what is dynamic table. Dynamic table is basically synchronous MVs, and it doesn't use by the query engine. But materialized view is the single level, the view, which is materialized view, and it's used by the query engine. I shared the link for the example use cases for dynamic part.
Yeah, Snowflake material view is always fresh. I think the same as the Gaurav mentioned about, that needs to be, because it does automatically query rewrite, so it requires always be fresh. The guarantee always fresh. Yeah.
But it is single level. There is no depth. The just table and materialized view. For materialized view, solution. For dynamic tables, there is a refresh settings, and it can be a cascading refresh, or the user can, disable the cascading refresh. Depends on the use cases. I will share that they call target lag, and this is the explanation. I just want to share everybody with the knowledge. That's why I.
So yeah, I remember in the MV spec, we also discussed that the target lag, right? Allowed staleness.
Yes. Yes, it's in the Google Doc, but I didn't see any configuration parameters specified in the view spec before. So, and the configuration parameters, I think they're kind of in the main documentation and not part of the spec, like for the table, for example. So I didn't want to include these configuration parameters that we discussed in the spec, but I can include them, or maybe create another document or another place, or maybe just add it to the documentation. But we did discuss this, and also kind of this this lag window, how long you would consider Materialized View fresh. So if you know that it had, like the last snapshot has been created within the last minute or 5 minutes or whatever, you would always assume it to be fresh and not even go checking if the source tables changed. But yeah, as I said, this is in the documents, and I could include it in the documentation. Or if you say that it should be part of the spec, then I could also add it to the spec. But as I said, since I didn't see, for the table, for example, I didn't see the configuration parameters as part of the spec, I didn't include it.
So any objection of including this config in the view spec? This will be part of view spec, right? Not the...
I actually, so I think that there's an important thing for the whatever we call this property, target lag, freshness interval, whatever we call it. And that's because materialized views, at least in this approach, can be consumed by engines that don't know how to interpret the SQL and don't know how to refresh the table, as long as they know it's fresh, right? And so if I am forced to calculate freshness, then I have to understand the SQL. I have to, or, I need to be able to evaluate all the tables. If there's an easy way for us to work around that and allow, like a Python client, that's the one that I think about most, is just like, PyIceberg, can somebody load from a materialized view? They're not going to be able to refresh it. They're not going to be able to run the, the SQL directly, but maybe they can get access to the data. And how can we make that easy for those cases where it's just like, yeah, as long as it's within an hour, it's going to be fine. And you define that on the materialized view.
So then I talk about the client query the material view storage table directly, right? Without going through the view. So if we can support that, I guess then that freshness config need to be done in the storage table. And that fresh config need to be stored in the storage table.
No, I think you still have to go to the view first, right? You're not going to access the storage table directly, but you can read. I mean, since you're going to reference it anyway by its identifier. You're first going to the view of the materialized view, and there you can see the config option. I think we called it max staleness or something like that. And you see, okay, I mean, you have to go to the storage table anyway to get the data. And then you see, the last snapshot was produced, I don't know, 20 seconds ago. So it's still okay. And then I just use the data that's in the storage table.
So Daniel, I think for the use case, you talk about if the client queries the storage table directly, I guess there's no question to check.
It's not directly. It's what Jan is saying. Like the client is going through the view, but it can't, like, it's not going to interpret the SQL itself, but it can then from the view go to the storage table. And if it can determine it's fresh, it can read the storage table,
I see. Okay.
Right? So it is going through the view. Like all of this goes through the view. It's not like I'm bypassing the view to the storage table.
Okay, just can answer SQL dialog. Okay, I see. Yeah, okay, that makes sense. So any objection?
Jan, where do we have the max freshness? Is that in the spec proposal in the view definition?
No, it's not included in the PR, right?
That's what I was.
No, it's not included in the PR. It's in the document. I think it was part of the properties at the end. It's just a configuration option.
Okay, maybe let me
that you can specify.
Yeah.
That's good. Any objection of bringing this config to the spec PR that Jan is working on? Anyone think this bad idea to have that the config in the view spec change?
I'm trying to decide between, I think it's what Jan was talking about. Do we include it as a property that then we have like a, a reference for how do you interpret the property to handle this versus actually making it a well-defined field within the view specification?
So right now the view spec have only one field called like a story table reference, right? That's where the one change. Maybe we can suggest a second field, max staleness.
Well, it's either a field or a table property, or a view property, right? Those are the two ways you go about doing it.
So other way is, I think store the max staleness in the story table also may not be. Okay, either way we need to.
Well, the storage table has a couple things. Like remember, it has like when the actual refresh was started. So you have a timestamp for that. You have a timestamp for the snapshot ID, and then I think it would just be figuring out, well, which time should be used to determine freshness, right? If you are evaluating for the staleness window, because you obviously can't rely on those things for any full depth evaluation, but if you're purely evaluating for staleness window, you could use one of these other timestamps as hey, the last refresh interval was started at this time, so I'm still within the window.
Yeah, I think either one will work. Put in the view or put in the story table, either one will work.
But this is for the view, right? The view, it's related with the view, basically. It's not on.
It's related to the view. There's two places you can stash information like this. One is a well-defined property that we add to the view specification. So we would add storage table and max staleness. Or you just add storage table to the metadata representation, and then in the view properties you put max staleness, right? And then the question is just like, how do we define the behavior for that property and how it should be evaluated? Do we do that as part of the spec? I need to think about that. I don't have a strong opinion right now.
How about we take that off? But at the same time, we definitely should add that information. We can discuss where the best place to add it. Right. We should add it to config, but we can discuss offline on where to add it.
Yeah.
Okay. So any more topic on this freshness discussion? Any more questions? Right, Sean.
Yeah, but it's related to freshness, but it's orthogonal to what current discussion is. Like my question is, why are we using snapshot ID for determining the freshness of a table? The case I have in mind is, suppose I added a default value column into a table, read default. My view was select star. Schema updates does not generate a new snapshot ID. When I read it directly from the table, I read the new column with the read default value, but my materialized view will never be refreshed because there is no new snapshot ID created. Wouldn't it be better if we track the metadata JSON pointer, or we fix the what do we do in that case? Or is it fine to just call it as a stale view, or call it as a fresh view even though it's not, and I have a different behavior as compared to the table?
Okay, the default value is the initial case, because in this case it actually changed the data. If we change the default value for the read, it actually changed the data.
Hold on, let's explore that. I'm not sure that is actually the case, because we have an initial default and we have a write default.
Yes.
You can only set the initial default when you create the column initially, which would mean that it was not part of the materialization. And with the exception of like creating a view that is like a select star, you would not be able to reference that column. So I guess that like one part of the staleness evaluation may be, is the schema of the table the same as what was used in the snapshot to produce the snapshot, right? So maybe our freshness check just needs to include that in order to encompass whether like a select star case, which you probably shouldn't be using in views anyway, but like, you know, that could potentially be something. But I don't think it changes the data because you can't change the initial default. You can't go and just say like, hey, all those nulls that existed before, now they're this value, right?
Yeah, precisely.
Well,
It's for
if
newly
I,
added columns.
if I add a new column, but I agree, it only affects the select star. Select
Yeah.
star is the evil.
Yeah. Okay.
And rather than supporting the select star, can we persist the column list? Is this
Well,
can
no,
be the way?
you don't need to do that. Like you just need to check what schema was used to produce the snapshot. And if that's still the current schema for the table, and like that typically doesn't change very rapidly. So like that check should almost always be, yes, they still match. Then you know that you're still okay. If it has evolved, maybe you just blanket say, hey, the schema for this table has evolved, or you know, something like that. We need to do a refresh. Because if the schema for the table has evolved, they may have dropped columns too. That may be out of sync as well.
Mm.
Well,
So maybe
but if we have a chained view, that gives more complicated.
if what?
If we have chained view or chained material view, then that schema evaluation also can be need to be tricky.
Yeah, but I think a lot of this is just the evaluation question, right? Because with the exception of the view case, the view, like referencing a view, I'd have to think through what that evaluation looks like then.
If they both use select star.
Well, yeah, the select star case is always. But then what? Oh, actually, no. When you create a view, when you do a view definition, like because you have to define your output schema as part of the view definition, you can't use select star. Like that's not possible to define for the actual view output. But if you use select star internal to the query in some way, which can be done, that could change the output of the query.
So if we need to check the schema, then we need to add additional refresh state for schema ID.
I do think we probably will need to do some schema validation against what the current snapshot state is, for the reasons that Prashant mentioned.
Even data type can change, right? They can alter the column and say into long. This is type promotion.
Yeah, type promotion is probably still safe though, because like you've already persisted the values that are part of the state of the table. You don't have any new values. It's not going to necessarily change any of the results that are stored in the table, right? It's just not reflecting the coded version of it.
Or isn't the schema ID part of the snap or stored in the snapshot somewhere? Couldn't we check there that?
Yeah, that's what I'm saying. You check that against the current state of the table, right?
So we wouldn't need to store this in the refresh state because it's kind of implicitly defined what schema ID was used when you specify the snapshot ID.
Yeah. And you just need to know if it drifted. And then like if you want to get super fancy, you could check how it drifted, right? But it's probably easier just to fail because the schema evolution is probably going to be a pretty infrequent occurrence.
So if we check the schema ID, do we require always recursive check everything in the tree, in the lineage?
I'm sorry, what? If we
So for the schema ID validation, do we need to check it recursively throughout the tree?
I think when we check the state of tables, you always probably would need to check the snapshot, the snapshot that's referenced in the materialized view state matches whatever the table is, and that the table's current schema ID matches what produced that snapshot for all references. But that's a pretty straightforward check because you already have all that information. Like when you load the table, you have the current schema ID and you have the snapshot ID, ideally that you're referencing. So there hopefully wouldn't need to be any need to do expensive checks to validate that.
Okay. Good.
I have
Sure, go
one more question, and it's also related to freshness checks. So do we want to leave the freshness check still open for some cases? Like, for example, if I did a compaction on the table, we literally know the table has not changed or has not added new data, but it's a new snapshot. But it is of type replace, so we know that this snapshot is or generated from the replace operations. Do we want to go specific about the maintenance operations, like and in case the maintenance operation generates new snapshots, to define in the spec that we can treat them as safe, or it's just like up to the engine if they want to be intelligent in skipping the refresh and go from there?
Well, I mean, I think we should probably define what the validation rules are for freshness checking, right? Just go through how should we evaluate freshness? And I think that is an optimization, obviously, right?
Yeah, I don't know if we need to specify that in the spec per se, because engine can optimize. Hey, I know that it's just a replace, so it's essentially still fresh. Engine can choose to implement that.
Yeah, like I was thinking more like an appendix, like we do with other things, where it's like, hey, these are like implementation notes. Like this is how we evaluate freshness for reference implementation, just so where possible we can get consistent behavior around those things. But it's not a requirement of the spec, right? It's just kind of enumerating like this is what the reference implementation does. Kevin?
Yeah. Hey, we have 5 minutes left, so I just want to see if there's anything we want to summarize for either the next meeting or the dev list. I don't want to disrupt the discussion here.
Yeah.
Just it's been really helpful to listen in, but I just want to make sure that we're good to kind of figure out things to move forward.
That's a good reminder. Tyler, do you have anything quick before we kind of
Just I just want to clear one thing. As far as I know, we don't know if that snapshot is created by the compaction or some maintenance function, right? We don't have any tagging for those kind of internal snapshots.
We do. We know what kind of operation. So like a rewrite operation explicitly does not change the data in the table. It may change the physical layout, but it doesn't change the data.
But do we have, next to the snapshot some, the tags for that? Okay, thank you.
Yeah, it's the operation field. So in terms of summary, it sounds like the main takeaways were, one, we are leaving it up to the engine to determine nested freshness of things like materialized views. So I think that was that option 2 or was that option 1?
Yeah, option 2 will allow us. Yeah.
Okay. So I think we probably want to follow up on the dev list with like, this is what we're thinking for that case. I think we need to follow up on where do we put the max staleness and how do we want to handle that? Is it a property? Is it a field?
And it's a view or in the table. Yeah.
In the view or in the table. And then I think there's an open question. Do we want to document how we do freshness evaluation, or how we should? I think that it should be included at least as implementation notes.
Yeah, the third one is related to schema ID. We need to validate the schema hasn't changed. Yeah.
That's part of the freshness checks. Like, hey, what are the things that everybody needs to check for freshness, right? Like, how do you evaluate it?
Cool. So I'll set up another meeting 3 weeks from now. Meanwhile, we can discuss more deeply on those 3 and also some of the open questions. Okay. Any other last minute comment?
Thank you.
All right. Thank you, everyone.
Thank you.
Thank you, everybody.
Bye.
Bye.